Hi, I'm John, and this is my presentation about DevOps Application Pipelines. In this video, I'm going to be exploring DevOps, and I'm going to be looking at some of the stages, tools, processes that we would place around our application development, deployment, and integration processes. As part of this, I'm going to be looking at the real-world scenario of a banking application and providing examples of what a hypothetical team do for each of these stages. So to start with, what is DevOps? DevOps is the adoption of culture, philosophies, practices, and tools to facilitate efficient and iterative delivery of software. It's an evolution of traditional IT software and development practices, and it aims to bridge the gap between development and operations. So in a traditional approach, where we've followed possibly a waterfall methodology, and we had projects that worked through phases from requirements gathering to design, implementation, testing, and delivery. We typically had different teams such as development, operations, quality, engineering, and security that would work in isolation on these separate phases. DevOps enables us to bridge the gap between these teams by creating cross-functional teams with people of varying skill sets across these different areas into one team working towards a common goal. And this is facilitated using the tools, practices, and cultures as part of DevOps. Now, before diving into some examples of a DevOps application procedure, I'm going to use a real-world scenario as an example for each phase. And this scenario is a bank called Real Bills Limited, and they have an application which enables users to view their accounts, transfer money, and manage their finances. The architecture of the application is .NET Core with an MVC web front-end, API, relational database, and infrastructure deployed onto Microsoft Azure using Terraform. As part of this hypothetical scenario, the development team are working to add a new feature to their application that allows users to set up recurring payments between their accounts. So let's start with source code management. So we typically use Git repositories, which is the most widely adopted and current source code version control system that we use for managing our code. And in a Git repository, we typically have a main branch which contains the deployable, tested, and ready to use production code. Then, as we're iterating upon the application, we use branches where we can have new code working on new features and bug fixes. Typically, we'll have multiple developers that are working on different features, bug fixes at any given time, and branches allow different lines of code for those different developers without affecting each other or without affecting the production code which we know works, which is lying in the main branch. There are a number of branching strategies available, such as Git flow, GitHub flow, or trunk-based deployment, which the development team they make a choice of which branching strategy they want to use based on their needs. Ultimately, this branching strategy defines the process of how we get new features or changes to the application from the developer's machine into production. And there's many processes we can place around this. So in the example of our Real Bills Limited banking application, they use the GitHub flow branching strategy. The new reoccurring transfers feature is pushed to a branch which is from main, which would be effectively a feature branch. A pull request is opened to merge the branch to main, and the branch policy on main specifies that there must be a 90% code coverage, there must be a work item associated, and a senior developer must approve the changes. So these are some examples of what we can have associated as requirements for our pull request into the main branch. We then have continuous integration. So pushes to any branch may trigger automated actions for immediate feedback. And typically we would do more lightweight tests for pushes to feature branches, since we're going to have a lot of code changes and a lot of different branches running at any given time potentially. And it's going to use build agents and compute power to run these tests. So we typically have more limited tests and maybe a build verification, unit tests which are designed to be small and should run fast. So we would potentially have lightweight tests when we're pushing to our feature branches. This is subject to resource constraints. Then when raising a pull request, we may have the more comprehensive checks, all tests such as unit tests again, and integration tests, and end-to-end tests, static code analysis, and more. Artifacts for deployment produced before or after the merge, so we can have our artifacts that are used later to deploy to our different environments, can be created when, as part of the pipeline that runs when we make a pull request, or it can be part of a pipeline that is triggered once the code has been approved and merged into main. In the example of our real bills banking application, the unit test and build validation completes upon a push to the branch. The more comprehensive checks are performed as conditions of the pull request, and the artifacts are produced upon merge after a merge to main. The next area is continuous deployment and continuous delivery. So branching strategies guide how and when CI/CD pipelines are triggered and which can lead to environment deployments. So this is based on our personal choice. We can have as part of different branching strategies, we might have, for example, as part of the Git flow branching strategy, we would have a developer branch, which would serve as an integration branch where we do all of our pre-integration tests before releasing to production. So depending on if we take an approach like that, or if we deploy it to all of our environments from the main branch, by configuring the triggers to be like that, the branching strategy really defines how our environment deployments are triggered and actioned. The deployment artifacts are deployed to different environments: dev, QA, staging, and production, which is the artifacts created either during the PR or after the merge to main. And infrastructure as code is triggered as well as part of the application changes. So often when we're adding new components or services to our application, we may require new infrastructure to be provisioned. And when we've got infrastructure as code, such as Terraform, or in the example of Microsoft Azure, we could use native tools such as ARM templates or Bicep. The changes to the infrastructure should be part of the same pull request CI/CD processes. We would have different tests for infrastructure as code, such as link test, which would detect issues with the code. But that's all part of the same procedure. So in the example of real bills, the new infrastructure is deployed with Terraform, and deployments are triggered upon merge to main. There are separate pipelines for separate environments. Then we have applying changes to our database. So often as we make changes to our application, we're going to need new tables or changes to the database schema. And typically we apply database changes or migrations as part of the application deployment. New database changes are often required as part of the deployment of new features. So it can be problematic to do the database upgrade at a different time from the application. This can cause runtime errors if we've not conditioned our application for this type of database upgrade. With that said, database changes can be decoupled from the application deployment process, and in certain scenarios this will give advantages such as reducing deployment risk, or if we have large complex databases we might want to do it as a separate process. If we do decouple, this can be facilitated in various different ways. Some examples are feature flags, backwards compatibility, and versioned API endpoints. But decoupling is more complicated and requires a lot more design and consideration. In the example of Reabills Limited, we've got they're adding a new table called reoccurring payments as part of the new feature for reoccurring payments, and they apply the database upgrades as part of the application deployment by running a migration as part of it, database migration. We then have monitoring and feedback, and this is a key component of facilitating feedback loops and quick resolution of issues as part of DevOps. Cloud vendors often provide application level monitoring tools that may be integrated directly into CI/CD tooling. So an example of Azure, we've got Azure Application Insights, which can collect telemetry from the application, detect performance issues, monitor external endpoints, and let us know what pattern we're seeing with returned HTTP status codes. And we can integrate this directly with our CI/CD tooling. We can have work items created automatically. The Azure tooling often allows us to set up alerts for certain logs that have been detected, allowing the technical teams to be notified of issues. So in the example of Reabills Limited, they're using Azure Application Insights integrated with each environment to detect issues. So they will work using gates. The gates must say that there are no issues detected with lower environments before allowing the deployment to higher environments to continue. And then Azure Monitor is used to notify team members of anomalies via email. So as we're working for those environments, dev, staging, and then on to production, for each environment, there are alerts to notify team members of any issues that are detected. That concludes my presentation on DevOps Application Pipelines. Thank you for watching.